Welcome to DEF CON. All right, we got Lora, water meter security analysis. This is your presenter, Jun Lee. Give him a warm welcome.
Thank you, everyone. First, I'd like to clarify that this work is not only done by myself. It was done by my team members. And one of the members, because the U.S. consulate rejected him of his visa, so he cannot be here. So yeah, every year we got speakers rejected of the visa. I think this young man might be big national security threat for the U.S. consulate. Okay, I'm going to record a short video for him to get him what he feels to present in front of such a huge bunch of hackers. So everybody. Sorry. Okay, let's start out for Zeng in Tao. His name is in Tao. Okay. Okay, thank you. Yeah, every year I got many friends rejected. So let me quickly introduce my company and our team. My team is called Unicorn Team. We are doing wireless security, hardware security, and so on. And we are from the largest security company called 360 Security Technology in China. And today I'm going to present how the process we took to analyze this so-called smart water meter. So this how it looks like in real life. So on the left you can see it's like just look like the normal water meter, but there is a dial, the red circle. So that's just like a magnet. So when the water meter runs, the magnet will rotate, and there will be a magnet sensor on another cover on the next slides I will show you. And on the right is a solar panel powered gateway, which just like relays the water meter data to the server via the GPRS, but the communication between this water meter and the gateway is using Lora, which is kind of a proprietary protocol. And this is the cover of that water meter. When you disassemble it, there is a circuit board, and there is an antenna, and also this is the gateway, which you can see there is a GPRS module and the Lora transmission module. So this is actually the parameters of and the models of the chips. So you can see there is an MCU which is used to configure the Lora chip every time it pops up, because this might be. So we will later introduce how we can attack the communication between the MCU and the Lora module. And we have the antenna parameter and the battery. So this, the way why they are going to use this Lora communication, because it's low power. So this little battery can power it up to 10 years. So that's why they are using this. And there is a Hall sensor to detect the rotation of the magnet, as I said here. So I don't know if you can see it. There's a pointer or something. No. So there is a magnet sensor called TNR301 that can detect the water meters when it's running. And there is a MCU, so configure. MCU is here to configure this Lora chip. And this is a gateway disassembly. So there is a GPRS module here, the white rectangle, and there is a Lora module. So it's just like very typical architecture for an IoT device. And there is a EEPROM to store the data, maybe to when it's the GPRS to maybe buffer the water meter data. And actually, the gateway usually implement the gateway using a different chip, but they are using the same chip as the water meter. So they have to use, because this is cheaper than to use another like chip dedicated to for the gateway. Now let's talk about how we can like fix the water meter data. So you can, as we said, that they're just detecting the rotation of the magnet. So we can use a strong magnet to put it near the sensor TMR301 sensor to interfere the signal. So you can see when the magnet rotates, the voltage produced on the water meter, the sensor will change. So we can use, you can see if there's no point. Okay. So you can see that this, when the magnet is in this angle, there is a 400 millivolt voltage, and when the angle change, the voltage change accordingly. So that's how they can detect the water meter when it's running. So we use a strong magnet to interfere with this magnetic field. So because the cover is a plastic, so it's still working. So you can spoof the sensor data to say that we are not using any water. But this can be caught if they come to your house and actually take the look at the water meter. So that's one way to spoof the sensor data, and another way is just to disassemble it and use a like voltage regulator to spoof the sensor voltage. It's a same effect. So the Lora frequency is different in each country. So this is, for example, in the US is 915 megahertz. So in the other countries it's different. So when you're trying to like do research on this kind of Lora-based device, you have to maybe tune your SDR device to that frequency in order to catch the signal. So this is the format of the packets. So you have this preamble, which will notify the receiver that there's a packet coming, and you have this up chirp, down chirp that encoding data. So, and actually there is a very pretty complex set of parameters you need to configure. So when we do wireless research, security research, we often use like SDR. So we have to configure the parameters for the receiver or for the decoder. So there are many sets of configurations. So actually, researchers from the U.S. company Bastille, they are doing wireless security, so they did something to like to decode the Lora traffic. But we tried their code, but it's not working. I guess it's because the configuration of the parameters are different. So we have to write our own decoding code for this traffic. So actually, one of our team members wrote the code to using MATLAB to decode the traffic, and we uploaded this module to our GitHub. So if you are interested in doing some Lora research in the future, you can go to look at the code. But this is still not very easy to use. So we switched to another method. So actually, because as I said, there is a MCU used to configure the Lora module every time it's powered on. So what it does is using SPI serial communication to configure the Lora module, all the parameters, which frequency, and the different like spectrum factors, something like that. So we used the this logic analyzer to capture the traffic on the serial communication interface, and we can figure out how this Lora front and Lora transceiver is configured. So, and then we just go and buy another Lora module and use the same configuration in order to receive to decode the traffic. So it's pretty smart, this kind of. So you have once you got all the traffic on the serial communication, you have to figure out what those traffic means. So we got this. We figure out it by looking at the documentation where this is what kind of instruction means what. So, for example, when you see this traffic, it means that set the frequency to the 492.25 megahertz. That's the frequency we mentioned in the previous slides, where we say that different countries are using different frequencies. So you can see this is the Chinese frequency. Okay, now we got the configuration, so we use another module to configure it the same way, and we can sleeve the traffic. Okay, so now we got the traffic, we have to reverse engineer the communication protocol and see how they transmit the data. Surprisingly, we find it not encoded. It's just sent in plain text. Perhaps they think that Lora communication is by itself is very hard to decode. So they're using kind of like their proprietary protocol. So there's a unique ID of each water meter, and actually we can spoof all the traffic here. And they are transmitting the water usage data and also the temperature. So let's see if the privacy risks. For example, if I see that there is no water usage, because the water usage data is transmitted in plain text, so we can actually sleeve the data to say if somebody is at home using their water meter, and or so we can actually profile the habits of this user. So to say if his working routine, when he comes home and when he leaves for work, something like that. And we can also spoof the data to make somebody see. We can see that they are using a lot of water and get their overcharged. And we can also forge the gateway to issue instructions. For example, because this is the 4-duplex communication. This is the two-way communication. So not only the water meter have to upload water usage data, but also the server might issue some command to the water meter. So and also the Lora is not only used in water meter. So they are used to control gas valves or other just like you can think of similar like GPRS or ZigBee. They can be used anywhere to build a connected device. So if we can get the traffic or spoof the traffic, we can cause other chaotic consequences. So this is their how the communication links works. So the water meter actually sends the data to the gateway, and the Lora gateway to send the data to the server using GPRS. And GPRS, everybody knows that the traffic is that communication link is not safe. Everybody maybe can sleeve or spoof the traffic. So we can use fake base station to attack those, to do the man in the middle, or to just spoof the gateway. And So this is my colleague trying to sleeve the GPRS traffic. So we set up this base station using OpenBTS, and we managed to get this gateway to communicate to our fake base station. And actually, this is very common kind of attack especially in China. So people are using maybe this GPRS to unlock shared bikes. So people are trying to spoof the unlock command to make the bike open itself. Yeah, so we are doing that. This is kind of very common techniques. So when we got the fake base station set up and the gateway connect to our fake base station, we can see what data it is sending to the server. And we analyze it using Wireshark and to reverse engineer the protocol used between the gateway and the server. So this is how the traffic looks like. So you can see there's a gateway ID, there's a header and count code, and also payload. So all kind of information. Again, it's not encrypted. It's just using a CRC to check this integrity of this packet. So we can actually, as I said, we can spoof the gateway to transmit fake water meter data, water usage data to the server. So let's take a look at the overall communication link: the water meter to the gateway to the server, and so we have reverse engineered the two communication link, and they're using all kind of proprietary communication protocol. So the one is over Lora protocol, over Lora. Another one is using over GPRS. So let's once again to see this whole test environment. We have this magnet to interfere with the magnet sensor. We have this Arduino module used to configure the Lora module we used to sleeve the traffic, because we have reverse engineering the configuration process of the MCU to the Lora module. So we can use Arduino to configure our module to sleeve the traffic. And the next step is to using OpenBTS to analyze the communication between the server and the gateway. So in conclusion, that we can see that so there are, once again, we can sleeve in user privacy data to profile this user, and we can actually to forge the data in each stage. The Lora stage, where the water meter communication with the gateway, we can spoof traffic between the gateway and the server. So actually, we have to every time we break something, we have to figure out a way to actually remediate or just to remediate it. So this is using Lora WAN protocol. This protocol is brought up by Lora Alliance, and so we can use, for example, to prevent the data from being spoofed or forged. We can using message integrity, maybe hash maps used based on some kind of encryption key to check the integrity of the packets. We can also use some like encryption. I think that why didn't they use encryption in the first place is because this is like quite a low power application. The encryption may consume a lot of power. So that's why they didn't like encrypt the water meter in the first place, or they just like think like obscurity, like security, something like that. They think that Lora is hard to decode. It's not like the GPRS that you can easily like to split the traffic. So we prove that this is not possible. We can still like get to traffic. So they have to improve the security by encrypting this traffic in each state. So we have this. This is actually the Lora, the standard by Lora Alliance, and everybody can look at it. There are like the security measures, but it seems that they are not following it. So anybody have any questions? This is a reference. The Bastille research, they have done a great job by like providing people with the code to decode the Lora traffic, and we have this all kind of resources. So anybody has questions? Or no? Okay, you. Okay, I will try my best to answer your question. Shoot. How can the company protect their infrastructure? You already deployed infrastructure. How can they protect that? Yeah, I don't think they can actually do that, because usually when you use this kind of communication, you don't implement some kind of over-the-air update mechanism. So you have to like maybe replace the infrastructure. So you have to think of security in the first place. Or they just like, for example, the magnet stuff. You can change the plastic cover into a like metal cover. And so that will be prevent somebody used to interfere with the magnet sensor using a strong magnet. So if somebody don't want to pay water fee, they just put this magnet on the water meter, so it's not running. So yeah. So anybody else has a question? Okay, thank you.